Thanks, everyone, for being here. My name is Dang Song. I'm a professor in computer science at UC Berkeley and also a faculty director of Berkeley Center for Responsible Decentralized Intelligence. And today I will talk about towards building safe and secure AI, lessons and open challenges. And also I wanted to say that I'm really glad to be here in Singapore. I really love Singapore and I've been here many times. Actually, a number of my former students and postdocs are professors here, so it's great to be back. Okay, great. So we are all really excited about the fast advancements in frontier AI, and not only we have seen great progress in the underlying models, and also it has been announced by leaders of various frontier AI labs that 2025 is a year of agents. So with all these great advancements, at the same time, there is also a broad spectrum of different AI risks. So this is a list of different types of AI risks from the recent International AI Safety Report led by Yasha Banjo, and I'm part of this effort as well. And this report is the first ever one that actually a great international effort supported by 30 countries, and also UN and a number of other organizations as well. And also, as we deploy AI, it's really important to consider the presence of attackers for a number of reasons. First, history has shown that attackers always follow the footsteps of new technology development, or sometimes even leases. And also this time, the stake is even higher with AI. As AI controls more and more systems, attackers will have higher and higher incentives to compromise these systems. And also as AI becomes more and more capable, the consequence of misuse by attackers will also become more and more severe. And hence, as we deploy AI, and also as we build safe and responsible AI, it's really important to consider the adversarial setting. And also I want to briefly talk about the AI safety versus AI security. So AI safety overall is about preventing harm that the system might inflict upon the external environment. Whereas AI security is about protecting the system itself against the harm and exploitation from malicious external actors. And also the two has a lot of has a lot of intersection as well. In particular, AI safety needs to consider the adversarial setting. Essentially, AI safety also needs AI security. So the goal to talk about safe and secure AI, it's not just about safe and secure AI alone. It's really the goal to advance safe and secure AI innovation so that we can ensure its potential benefits are responsibly realized and widely shared. So AI safety and security really is a very big area, and there are many different topics and many different types of risks and challenges, as I mentioned. Given interest of time, so today in the talk, I'll mainly talk about two sets of challenges. One is how we can ensure trustworthiness of AI and AI alignment as we deploy AI. And then another challenge I want to talk about is how we can actually mitigate misuse of AI. And in the end, I wanted to briefly summarize a recent proposal that we have together with a number of leading AI researchers that we have proposed on a path for science and evidence-based AI policy. So first, let's look at how we can ensure trustworthiness of AI and AI alignment. So when deploy AI in practice, there are many challenges for trustworthy AI and AI alignment, as listed out here, just as a list of examples. And again, given interest of time, I won't be able to go through all of them. So I just wanted to share some of the stories and lessons that I have learned from my own journey on some of these topics, including privacy and adversarial robustness. So first, let's look at privacy, and also look at why this is important. So my group, and together with other collaborators from Google and so on, we were actually the first to set out to study the problem of memorization of these neural networks. So the key question is, as we know, neural networks have large capacity. So do neural networks remember training data? And if yes, can attackers extract the secrets from the training data from even just simply querying the learned models without even knowing the details of the models, such as the architecture and parameters and so on. So we were the first to set out to explore this question. So this was back then in 2018, 2019. So we first studied, back then the language models actually were quite much smaller. And here is one example that we demonstrated is that when we train a language model, for example, here using email data, publicly available data set called the Enron email data set, which naturally contains users' credit card and social security numbers. We can, through devising new attacks, we can actually automatically extract a number of these credit card numbers and social security numbers that were embedded in the original training data. And this is the first example illustrating that these language models, as we train them, they do memorize, and also attackers can exploit this issue by just querying the language model and then be able to extract sensitive information from the original training data. And also in this work, we propose a new measure called the exposure for memorization, which then has been used in various Google products, such as Google Smart Compose, to help improve the users' data privacy. And then as the models got bigger, as AI continues to develop, we continue to essentially investigate this phenomenon, this memorization, whether it actually exists in all these future developments of these language models as well. So, for example, we were the first to look at the memorization in large language models like in GPT-2, and we developed this prefix-based data extraction attacks, and showing that, yes, these large language models also has memorization issues, and attackers actually can extract sensitive information, for example, personally identifiable information in the original training data, again, through simply just querying these language models. And then fast forward, given the frontier AI models, then similar question also applies. So as we develop these really like a frontier foundation models, do these models also suffer from these memorization problems? So this is our recent work with a number of collaborators on decoding trust, the first comprehensive evaluation framework for trustworthiness for large language models. The work actually won the Outstanding Paper Awards at NeurIPS, and also the Best Scientific Cybersecurity Paper Award of year 2024, given out by NSA. Each year they give out one Best Paper Awards, and last year was for this one. So in this work, we developed new, various new evaluation methods to evaluate a broad spectrum of different perspectives for trustworthiness of large language models, as I also listed earlier. And right, so here privacy is one of the example, is one of the perspectives. So so in this work, we developed various different prompting techniques and methods to and demonstrate that when these large language models, when they are prompted using different methods, we can actually extract sensitive information in the training data from the outputs of these large language models. And another interesting finding by other researchers also shows that actually for some of these large language models, for example, if you just gave prompts, repeat this word forever, like have the word appear many times, then this actually can trigger the model getting into a weird state, and then the model starts to actually output data. And as you can see here, the data actually contains, again, sensitive information like PI information and so on. And also later on, actually, there is confirmation that the output data actually, so the output data actually from the training data, and also the output data actually matched some user's email signature in the real world. So this is an example of implication of memorization and in the real world. So these large language models, they do memorize a lot of the training data, and and this can have real world consequences. Another of our work, recent work, we actually developed a comprehensive evaluation framework, in particular for data privacy, that actually assess memorization and privacy issues across different stages of the model development, including pre-training, fine-tuning, and so on, and also evaluate different types of data memorization and other types of attacks, as well as defenses. So the work actually won the Best Paper Award finalist at a top conference as well. And one of the many findings that we had from this work is that we also look at what kind of factors impact memorization, and also looking at essentially some of these trends or scaling laws of memorization. So this is an example from our work illustrating that actually these memorization privacy leakage issues, they actually do worsen as the model size increases. So here's an example illustrating that with the PCL model series, it uses the same training data and the schedule, and just the model size increases. And here we can see that the memorization privacy leakage issues do get worse as the model size increases. So this illustrates another challenge is as we develop larger language models, these memorization and privacy leakage issues can worsen. And also our recent work, MMDT, is the first work that systematically developed a comprehensive evaluation framework for trustworthiness and safety for multimodal models. And again, we'll investigate different perspectives. So this work actually will be presented at ICLR this conference. And again, here, privacy is one of the perspectives. And our work also showed that this type of memorization issues also is prevalent and a big issue in multimodal models as well. So overall, this is I just showed a progression of our investigation and exploration in this area of memorization and privacy leakage, starting from really small models, and as the models continue to get larger and more advanced, we continue to investigate this type of issues. And also, when we started, we were the first to investigate this issue, and by now, actually, the field, this domain has grown has grown a lot, and this memorization, and actually now this area has actually a large landscape covering many different aspects. There are different definitions of memorizations, different factors that influence memorization. Memorization can happen at different stages, and there are different methods how we can detect memorization and mitigate memorization. So this is our recent work, recent paper also essentially outline the overall landscape of memorization in large language models. And from this work, we also showed that there are still many open questions and challenges in this domain. In fact, we are just scratching the surface. So, for example, what factors really impact memorization? How does the training process actually impact memorization? And what methods or tools can we develop for more effective auditing and assessment of memorization? So the hypothesis here, as what I showed earlier, is that actually the models can be triggered into this weird state, and then they start to essentially output training data. So, so the hypothesis is that models actually, they may memorize much more than what we currently can measure. So how can we develop better methods to elicit and measure such memorization much more effectively? And also this problem will become even worse and even more important and severe as we move into agentic AI and continuous learning. as we develop agentic AI and continuous learning, these models will actually continue to learn from the models, from the agent's interaction with the world, which can contain a lot of sensitive information. And hence, the problem will only become more and more severe. And then, given this, then what methods can we develop for more effective mitigation for memorization? So far, as a field and also as our own work, we have studied different mitigation methods, including data cleaning, deduplication, differential privacy, machine unlearning, and activation steering. We've studied all these different methods, but this, again, is still just a beginning, and it's insufficient. We need to develop more effective methods for mitigation for memorization. So that's the first area on privacy. The second one I want to briefly talk about and share lessons from my journey is on robustness, in particular for adversarial robustness. In the earlier seminal work, the researchers have proposed these adversarial examples, have discovered these adversarial examples can fool deep learning systems where you can add very small perturbations to the inputs that can actually fool the model to give the wrong answer. And my group has been among the earliest to broadly study this area for adversarial examples and adversarial attacks in deep learning systems. Our work and others' work have demonstrated that adversarial example issues are prevalent in deep learning systems. And our work is the first to demonstrate that adversarial examples can not only be effective in the digital world, but also can be effective in physical worlds that remain effective under different viewing distances, angles, and other conditions, and so on. So here's an example with a physical world stop sign with different perturbations that can be used to fool the image classification system and remain effective under different viewing distances, angles, and other conditions. And we have the rare honor and pleasure that the artifact of our work now is part of the permanent collection at Science Museum of London. So if you go there, you can see our artifacts exhibits there. So now, fast forward, moving into large language models. Again, the question is whether these adversarial examples, adversarial attacks, are also effective in the space, and what are the potential consequences. So in our decoding trust work that I mentioned earlier, one of the perspectives is in robustness, and in particular adversarial robustness. And our work also shows that through developing different adversarial prompts, we can, again, cause the model to misbehave, give the wrong answers, and so on. And overall, with our assessment framework, we evaluate many different perspectives, as I mentioned, for trustworthiness, and the results show that today's large language models can be easily attacked and have many different types of risks. And similarly, extending our work from text domain to multimodal domain, again, in our paper that will be presented here, we also show that these multimodal models also can suffer from these adversarial examples. And actually, for multimodal, the problem is even worse, that we can generate these adversarial examples even more easily, given that image domain is much easier to perturb and cause the multimodal models to misbehave. And also, these adversarial attacks not only happen at inference time, as I showed, with these adversarial examples, through essentially prompt engineering and jailbreaks and so on, they also can happen at other stages of a machine learning pipeline, in particular, for example, during the training stage, including both pre-training and fine-tuning, through what we call data poisoning. So again, my group is the first in the field to actually investigate the issue of data poisoning and also backdoor issues back then, like several years earlier. And our work showed that in this case, this is for a facial recognition system, that by injecting just a very small number of, a small fraction of poisoned data in the training data sets, the attacker can cause a machine learning model to learn the wrong model. And also in this case, it can actually have these backdoors such that when during normal circumstances, the model can behave correctly. But for anyone who wears a particular type of glasses, it actually can cause the model to misclassify, misrecognize the person to a target person. And this, and again, fast forward to large language models, similar issue. Also, these data poisoning and backdoor issues can also be a severe issue in large language models as well. So, for example, work from Anthropic showed that you can actually train these large language models such that during, with data poisoning, such that during normal circumstance, the model will generate fine normal code generation. But when certain phrases appear in the prompt, then the model will actually start generating vulnerable code. And also this type of phenomenon can even persist after the model has been safety fine-tuned. And also our recent work, Agent Poison, showed that this type of issues with backdoor can also be a severe issue in the agent setting as well. And in this case, through backdoor with the RAG, the attackers doesn't even need to train the model. The poison data can be embedded in essentially in the RAG database, and this can cause the model to essentially, under certain trigger phrases, the model can misbehave and retrieve malicious malicious actions scripts from the RAG system. So far I just shared some example domains and lessons from my own journey. And overall, so the lesson I want to share here is that when we started investigating these issues, the models were much simpler and smaller. But as the models become more powerful and larger, actually these risk issues are actually, they persist and they are becoming worse. And also at the same time, we are seeing huge gaps between the level of risks and of our level of understanding as AI advances. So the gaps actually widen between the level of risks and level of understanding as AI advances. And also the level of risks and also the level of our defense ability, there's also a big gaps, and the gap also widens as AI advances. And in particular, so when we started working in this area, in this space, back then there were very few papers, only like a handful of papers published in a year, actually at top AI conferences. And now the field has grown exponentially. So now there are many thousands of papers published in the space every year in adversarial deep learning. However, most of this progress, unfortunately, actually happens on the attack side. And in contrast to the rapid progress on these new attack methods being developed, the progress in adversarial defenses has been actually extremely slow. And so, and today we actually don't have effective general adversarial defenses. So as you can see, as the model and AI advances, this gap really continues to widen, which is a serious issue for deploying AI and for the society to really be able to benefit from the great AI power. To address these challenges, we need to actually address them throughout the different stages of AI lifecycle. We need to harden the AI models and align these models through data preparation, pre and post training stages, and also during the inference and deployment stage, we need to develop greater monitoring and control methods to ensure that the AI models does not create harm. And also, post-development, it's important to better understand the models and do better risk assessment and evaluation for these AI models. And also, as I mentioned, so far we have very limited, the whole community has made very limited progress on developing new defenses. And in fact, I argue that we need to develop new paradigm and push forward frontiers for safe and secure AI. In particular, develop new technological paradigms to actually be able to better address these issues, including in providing properly safe guarantees, which I'll mention in a second. So overall, as I mentioned, there are huge open challenges for developing AI safety. And in particular, these AI safety mechanisms need to be resilient against adversarial attacks. So far, I have shown that current AI alignment mechanisms are easily evaded by adversarial attacks. And any effective AI safety mechanisms need to be resilient against adversarial attacks. And adversarial robustness, as I mentioned, is a huge open challenge. It's a huge open challenge for achieving AI safety. So, as I mentioned, so we need to be able to, so we need to develop new paradigms and new methods. So one I want to briefly mention is in the in the area of what we call representation engineering, where during inference time, we actually develop, so we build monitoring mechanisms to monitor the activation of these neural networks. And we develop essentially different models on this in the activation space. And our work in collaboration with others show that we can, for example, identify certain directions in the activation space at different layers that actually corresponds to different types of behaviors of the model, and that we call representation reading. And furthermore, by leveraging these identified directions, we can, during runtime, amplify, for example, the activation along certain directions, modifying the activation in certain ways that which can then actually modify the model behaviors that we call representation control. For example, our experiments show that through these methods, you can make the model behave more honest or more dishonest, and so on. So this type of methods can actively steer model behaviors during runtime. It's an important, essentially, it's an important tool in the arsenal for ensuring AI safety, given that this is one of the, actually leveraging one of the benefits of these artificial neural networks in comparison to, for example, human brains, is that for these neural networks, we can actually completely observe during runtime their activations and so on, and we can actually modify their activations. So this actually gives us a very important method for behavior control for these models. But however, these methods do not give us quantitative guarantees. So recently, we also, together with other leading AI researchers, we've also launched an initiative on quantitative AI safety to develop new paradigms and new approaches for providing quantitative guarantees for AI safety. So that's the first part on ensuring trustworthiness of AI and AI alignment. So now let me talk about the second category of challenge, is how we can mitigate misuse of AI. So as I already mentioned, there is a broad spectrum of AI risks. However, I do personally believe that cybersecurity is one of the biggest AI risk domains. For a number of reasons, today already attackers have diverse incentives to launch attacks, and today attacks already cause huge issues. And also recently we have seen fast progress in AI capabilities for reasoning and coding and so on. Such increased AI capabilities can significantly reduce attack costs and increase attack scale. And also today, we're already seeing Gen AI causing attacks increase, in particular in social engineering attacks, phishing attacks, and so on. So one key question is, how will frontier AI change the landscape of cybersecurity? So here we have the traditional cybersecurity with attackers and defenders, with the traditional software systems, which are symbolic programs written by humans. With frontier AI now, AI as a dual-use technology can assist both attackers and defenders, and also now the software system also becomes much more complex, includes both symbolic programs written by humans and AI, and also non-symbolic components, which are these AI models like neural networks and so on. So the question is, given that the frontier AI as a dual-use technology can help both attacker side and defender side, who is frontier AI going to help more, attackers or defenders? So in our recent work, we set out to investigate this question. And in particular, we propose to use a marginal risk assessment framework to analyze this question. And in order to do this, we need to know the enemy, analyze the impacts of misused AI in attacks, and know the defense, and analyze the impacts of AI in defenses. And also we need to understand the natural asymmetry between attacks and defense. So first, let's look at how misused AI can impact attacks. And in here, when we talk about attacks, there are two main categories. The attacks can attack machines, the computer systems, and also can attack humans, such as phishing attacks, social engineering, misinformation, and so on. And also when we talk about attacks, it's very, actually, in general, cybersecurity attacks are very complex, and end-to-end attacks oftentimes has many stages that actually enable the end successful attack. So again, my group actually was the first to investigate and also apply deep learning in the domain of cybersecurity a number of years back, in particular for using deep learning for binary analysis and vulnerability detection. So our work back then already showed that actually deep learning-based approach can be very effective and achieve state-of-the-art in program binary similarity detection, and also was able to detect vulnerability in real-world program binaries. And fast forward, with the large language model capabilities today, research has shown that these large language model LM agents can autonomously hack websites, albeit simpler websites, and also can exploit one-day vulnerabilities. And also recently work from Google also shown that they were able to find 0-day in real-world large software such as SQLite and so on. So with all these advancements, however, so it's important to really evaluate how much actually does frontier AI today really impacts on the attack side. And recent work such as SciBench and also our own work and so on have evaluated these frontier models and also agents in areas such as like capture the flag, CTF tasks, and so on. So the conclusion right now is that currently these models' capabilities, these models and agents' capability is still limited. For example, in these real-world CTF tasks, they can only solve for task difficulty level as comparing to humans. That they can only solve for very simple tasks, where humans, the fastest human, take only about 11 minutes to solve. So this is their level of ability. So essentially, these models and agents currently they still struggle on the more difficult tasks. So this is on how attacks on machines. However, on the other hand, attacks on humans actually is a very different story. So first of all, in cybersecurity, we know that humans are the weakest link in cybersecurity. And actually, a huge percentage, there has been estimated that over 80% of penetration hacks actually starts from attacking on humans, like social engineering attacks. And today, most common cyber threats facing business and individuals today is attacks on humans through such as phishing attacks and so on. And we've already seen Gen AI causing orders of magnitude increase in social engineering attacks and with very sophisticated attacks. So overall, to summarize, in our recent work, which you can get from scanning the QR code here, we have done a comprehensive study surveying hundreds of papers published recently, studying the AI capabilities and impact levels on attacks and defense. So a quick summary of our analysis showed that in attacks, also as examples I showed earlier, on the attack side, for attacks on machines, most of the AI capability impact is actually very limited. Today, we are only seeing some very early signs of impact of frontier AI in making these attack stages more effective. It's actually very limited. But however, on the attack on the human side, this is a completely different story where we see large-scale real-world impact for this frontier AI on making attacks more effective, and the orders of magnitude increase already for attacks on humans. On the other hand, for the defense side, unfortunately, the AI capability and impact levels on defense side is even less than the impact on the attack side that we see today. So today, there is actually very little, except for certain stages for defenses. For most of the stages, actually, we don't really see much impact of AI capability and impacts at all. And in some stages, we don't see any demonstrated effects. And in most of the stages, it's still at the research stage. So our goal, of course, is that we want to advance AI to help improve defense side much more. But however, given that AI is dual-use technology, this has a natural challenge. In particular, as a dual-use technology, the same technology that can be used to enhance defense capabilities can also actually help enhance attack capabilities as well. So we call these equivalence classes, and we list out at different stages of attacks and defense. There are these equivalence classes between the defense capability and the corresponding attack capability. So this makes AI particularly challenging in the cybersecurity domain. Again, the same capability that advances defense can advance attack as well. And furthermore, there's a natural asymmetry between defense and offense. So there's one argument, like oftentimes we hear, that, oh, we don't really need to worry. So with the frontier AI can help discover and fix bugs, and the defenders can use this before attackers. So then problem solved. We don't need to worry. Is this true or false? True or false? Okay, right. So the correct answer is false. Okay, for a number of reasons, especially between the asymmetry between defense and offense. So on the offense side only needs to find one successful attack that works. But for defenders need to fix all bugs and prevent all attacks to succeed. And also, cost for defense is oftentimes much higher than attacks. And deploying defense, even when it works, also takes a very long time for a number of reasons. It needs to develop the fix, and then need to do a lot of testing of the patches, and then need to do the deployment globally. And a lot of legacy systems today are still not patched. And attackers can even learn about the vulnerability and generate exploits using public information of the patches, as illustrated actually by our work like a decade ago, and can exploit systems before they can even be patched. And this is just one of examples of the natural asymmetry between attacks and defense. And in our paper, we also showed other asymmetries for example, cost of failures. Attackers have much higher tolerance of failures since they just need to make one attack succeed, whereas defenders have much lower tolerance for failure since a failure means that the system will be attacked. And also there are different priorities of scalability and reliability. Attackers prioritize over scalability so they can scale out their attacks. Only if, even if just some of them succeeds, then the attackers wins. Whereas defenders need to focus on reliability since that they need the system to be reliable to actually run. And also, as I mentioned, now with agentic AI, we are going to have more hybrid systems, and this actually causes even more attack surfaces and security challenges. So overall, the consequence of misuse AI in attacks is vast. So today, we're already seeing, as I mentioned, misuse AI in attacks increasing. And also, misuse of frontier AI can completely change the attack landscape, can help with every attack stage, can apply to every attack domain in the attack landscape, can increase attacker capability, devise new attack methods and strategies, can reduce resources and costs needed for attacks, and change economic landscape of attacks. And also can automate large-scale attacks and make attacks even more evasive and stealthier. So the question is, what can we do to then address this issue, given the natural asymmetry between attacks and defense? How can we develop more effective defense paradigms? So over the past several decades in cybersecurity, including my own work and also the community, we have learned lessons, and there has been paradigm shift in the type of defenses that we deploy. So the initial early stage defense was reactive defense, which the goal is to detect once attack happens and then try to block these like malware and so on. But however, with this type of defense, actually, for a number of reasons, like given the interest of time, I won't have time to go into, AI actually can still help attackers more than defenders in reactive defense, such as network anomaly detection and so on. So this paradigm doesn't really help. So the next paradigm is through bug finding. As I already mentioned, this paradigm also doesn't help, like it can still help attackers more than defenders, at least in the near term. So what we hope is the actual paradigm that can help us is secure by construction. So the safe and secure by construction is to architect and build provably secure programs and systems through a formal verification. So in this case, in contrast to bug finding and attack detection and reactive defenses, we can formally specify security properties of a system and then formally prove that the program and the system actually satisfies the given security property. And luckily, I would say now we've entered into the era of formally verified systems. Now there have been various systems, including compilers, microkernels, file systems, and so on, that thanks to the efforts from formal verification community, there are formally verified versions of these. But however, one issue is that these systems are actually not widely used at all. And the main reason is that it's actually labor intensive to do the program verification. So for example, SAL4 took tens of proof engineers to prove. And when you change the program, you also need to change the proof. So in order to address this issue, so my group, we were among the first to use deep learning to automate theorem proving. And right, so this is our earlier paper, actually together with Ilya from OpenAI back then, where we showed that deep learning can help improve the effectiveness, improve automation in certain stages for theorem proving. However, back then, still, the model was, the technology was early, model was weaker and smaller. We didn't have much compute. Fast forward, I do strongly believe that now we are hitting an inflection point where we, with the recent advancements in AI and larger compute and so on, we can actually significantly advance AI to help with the formal mathematical reasoning and program verification. So with this approach, we hope that we can develop effective AI agents that's not just to play games like Go, but actually can develop proof agents to help us to automate theorem proving. And when together with program synthesis, we can then generate provably secure code that has both code and proofs. So with this approach, we can then use AI to help us build provably secure systems that can actually then really use AI to help defenders much more than attackers in this secure by construction approach. So given the interest of time, I won't actually go through. You can check out our recent paper where we lay out actually a roadmap for the community to come together to address the open challenges in AI for theorem proving, to then to come together to develop open source, collaborative open source efforts to actually build AI, frontier AI solutions for theorem proving and program verification. So with this approach, instead of just generating code where we have no guarantees of the security and correctness of code, instead we aim to enable verifiable code generation, where we generate code and formal specification and proofs together to prove that the generated code actually satisfies the given specification and security property. So in our recent work, we also developed the first data set for this task for verifiable code generation that contains all these three tasks. And with this benchmark, the current AI systems and agents are still at a very early stage and that cannot do these tasks well. But we hope that with the advancements of frontier AI, we can develop more effective proof agents to enable this verifiable code generation. So, right. So with that, I actually won't have time to go into the details. So I also wanted to briefly mention that this approach, currently we think that we can make it apply to traditional systems. But as I mentioned, the agentic system actually is a hybrid that includes both traditional components and also these non-symbolic components. And these agentic systems actually can have much greater attack surface and have much greater security issues. So in our recent work, we also developed a new secure agent framework to try to provide approval guarantees for the agent framework to satisfy certain security policies. So we hope that by developing frontier AI technologies, as I mentioned here, we can also extend the secure by construction approach to hybrid systems as well. And in the end, besides using AI to help advance advance technologies for defenders, we hope that we can also use AI to help develop these essential shield assistants to help protect users, to intermediate communication between users and external systems, to protect users against these social engineering and phishing attacks as well. So to summarize, AI will help attackers more at the beginning, and as cost of AI going down, we expect to see unprecedented increase in attacks. The world was not prepared for pandemics such as COVID, despite early warning, and attacks assisted with AI can become much worse. So I also wanted to briefly share our lessons learned from another domain, a related domain on medical device security. My group, together with other collaborators, conducted the first medical device security analysis in the public literature, showed that certain medical devices, such as defibrillator, had critical security vulnerabilities. Back then, FDA medical device approval process didn't even have mention of security. So only a few years later, following on our work and others' work, FDA issued guidance recommendation on medical device security. So the lesson to learn here is that security space is complex. Frontier AI will have huge impact in cybersecurity. And hence, it's important to learn from past lessons and act now. So with that, I've talked about the two challenges, ensuring trustworthiness of AI and AI alignments, and also mitigate misuse of AI. So our goal is to advance safe and secure AI innovation to ensure its potential benefits are responsibly realized and widely shared. And with this, we also actually need a social-technical solutions, not just technical solution alone. So to address this challenge, recently, together with other leading AI researchers, we set that a new proposal for a path for science and evidence-based AI policy that you can go see at this website. And the proposal emphasizes that AI policy should be informed by scientific understanding of AI risks and how to successfully mitigate them. And the current scientific understanding is very limited, and hence we need to prioritize advancing scientific understanding of AI risks and how to successfully identify and mitigate them. And if you want to get more information about our work and impacts of frontier AI in the landscape of cybersecurity, and also help out with the survey that we are launching in the space, you can scan this QR code and fill in the form. And also, we are running a MOOC, Massive Open Online course on large language model agents with over 23,000 enrolled worldwide. And you can learn more information and join us here as well. With that, thank you.
Can we have some questions? If you raise your hand, our volunteers can rush over to give you the mic. Yeah.
Okay, thanks for the wonderful talk. And clearly it has very strong and practical implications. So say, we were analyzing some discussions on GitHub. We noticed that developer basically almost every month report that the GitHub Copilot may release some, leak some privacy information like OpenAI API keys to the end user. So it's quite problematic. The question I have is about the backdoor attack. So in your research, have you ever noticed some evidence that the models you are using right now, currently every day, say GitHub or Copilot or like OpenAI, they are actually being attacked by data poisoning or have backdoor that may affect our daily life?
Okay, that's a very good question. So first of all, there has been research demonstrating that, first of all, given that these models, they are trained with data collected from the internet, so there has been research demonstrating that such data poisoning attacks can be feasible. Yep. And also, there has been reports, for example, on Hugging Face, there are models, in this case, it's not exactly backdoor, but there actually have been models that are with like malware embedded and other attacks embedded, yep, and so on. And you can easily imagine that, right, so there are like models, there can be these poisoned models on these, right, like Hugging Face and other places as well. And the one challenge with this backdoor is that they can be really stealthy. So it's very hard actually to know whether these models have backdoors or not. But yes, I think going to the future, given that these type of attacks can be very effective and can be very stealthy, I think we can envision that, right, these
yeah, that's also highlighted in your statistics about the survey of different types of works on attacking and defending the model. So probably there are some stealthy attacks but cannot be detected by current methods. So the community
absolutely.
may need more research on this.
Right.
Thanks.
Right. Okay, thank you.
Yep. Can we have another question? Yes, there.
Thanks, Prof, from the talk. I'm Ping Yuen from AI Singapore. So I actually have two questions. In your talk previously, you talked about actually currently now there are actually no effective general adversarial defense, right? So my first question is actually, do you foresee in the next maybe 3 to 5 years this gap can be breached? And actually specifically my second question is, what are some evergreen problems particularly related to safe and secure AI? Because fundamentally we know cybersecurity, attack and defense is actually a cat and a mouse game. So are there some evergreen problems that we just can't possibly solve it once and for all? Thank you.
Okay, yeah, thank you. That's a very good question. So first of all, on the defenses against these adversarial attacks, as I already mentioned in the talk, unfortunately, currently the community has made very, very little progress. So large language models, given the discrete domain, actually does make some of the attacks harder, but actually, as I showed with the multi-model, actually it's actually it's very easy to do the attacks. And so that's, but we really don't have very good defenses against these adversarial attacks at all. So that's why I mentioned with these new paradigms and new approaches that we actually, with the community, we really need to put more efforts, much more efforts in to explore these new approaches and new paradigms and so on. And with that, for the second question, so that's what I mentioned, especially for AI as a dual-use technology, it can help both attacks and attacker side and defender side. We really need to get out of this cat and mouse game because otherwise, right, as I already showed, with the natural asymmetry, attackers can actually benefit more. So that really motivated us to do the secure by design, safe by design approach. Is that if you can build systems with provable security guarantees, then in this case, then the defenders actually that has the advantage. Essentially, given that it's probably secure, that at least certain classes of attacks, attackers will not be able to do at all. So that's why going forward, we also hope that more efforts can be put in so that we can develop more of these secure by design, safe by design approaches. This is also the motivation behind this quantitative safe AI new efforts that together with Joshua and others that we launched recently. It's really to get out of this cat and mouse game and really focus on developing new approaches and solutions with approval guarantees.
Thanks, Prof.
All right. With that, in the interest of time, let's thank Professor Sloan again.